Now, I can be intrinsic geometry, exterior algebra in 3D. B, part 2, manifold, push forward and push pull back. Now, lecture 12, say part 2, push forward and pull back, apply to cotangent space TP asterisk M. Now, M over here could be the polar coordinates, okay, and N would be in this Cartesian coordinate. I'll write like here. I think it's more complete. Space M T Q N. See, this is better because here we work with two manifolds, M and N. Now, set up, let F is R squared, mapping to the polar to Cartesian. F is R cosine and R sine. You see? Now, attention now. The function G, attention now. Coordinates are functions. So, the function G is equal X or G is equal Y, a function on Cartesian coordinates. You see, this is one at a time. One at a time. Now, let X be, this is a vector, okay? This is VR dr plus V theta V theta. Attention now, R and theta here are lower indices because we are talking about cotangent space. You see, dr and d theta are the basis vector belongs to the cotangent space. Now, YQ, you see there's a push forward XP, Vx dx plus Vy dy. Attention now, this belongs to this cotangent space here, T asterisk Q. Now, we use the adjoint operator identity, okay? Just to use the pullback and the push forward, or the push forward and the pullback. Doesn't matter. So this is the relation here. We wrote this many times. You see, this is adjoint operator identity over here. It's better to put the identity symbol here. Now, step 1, from polar to Cartesian, okay? Express dr d theta in terms of the x and the y. You see, polar to Cartesian, you see, it's important for you to know that I will express the theta in terms of the x and y. So x is equal R cosine. So the differential of x, this is a vector, okay? The x is a vector. The cosine dr minus R sine d theta is equation 1. Likewise, y, you see dy, you just derive, okay, partially sine theta dr plus R cosine theta d theta, equation 2. Let us invert, multiply 1 by cosine and 2 by sine and add. It's quite easy, you see? You multiply and add. Then this leads to, this is here, this is 1, you see? So this is a dr. So dr in terms of the x and the y. Now for d theta, again, multiply 1 by minus sine theta and 2 by cosine of theta and add. You see, then this leads to minus sine theta dx plus cosine theta dy is equal R cosine square d theta plus R sine square. Again, this is sine square plus cosine square is equal 1. So this is R d theta. So if I explicit d theta here, you divide by r. So this d theta and the r represents, okay, in this case, okay, the cotangent basis, the r, the theta, in terms of the x and the y. See? Now let's express the components in terms of Vx and Vy. Attention now, V is invariant, okay? Does not depend on the coordinate system. So this equality over here, Vx dx plus Vy dy is equal, you see, all this is vector V, you see, the same vector, okay? Now substituting dr and d theta, okay, just on the right hand side, this you just look at here, it's quite easy. Now you can group, this case, you can group the x and the y, you see? So this over here, I forgot to write, this is the x, you see, you just copy from here to here. So again, you compare Vx, you see, Vx that multiply dx, just write down here, Vx, Vr cosine plus V theta minus sine theta divided by r. Likewise, Vy is Vr sine plus V theta cosine divided by r. Now, so the inverse system is solving for Vr and V theta, okay? Multiply the first by cosine and the second by sine and add. Just easy, okay? Now I will obtain Vx cosine theta plus Vy sine is equal to Vr that multiplies 1. So this is a Vr in terms of Vx and Vy. Remember that cosine of theta is just x divided by r, and sine is y divided by r. R is the square root of x squared plus y squared. So then, don't forget that I just multiply the first by minus sine and the second by cosine and add. You see? Then I would get V theta, okay, and Vr. That express the components. Attention now. V theta, Vr are covariant, belongs to the dual space. Go back that part 1, part 2, you see, and study the space vector and the dual space vector called covector. That's it. That's a very, very important relationship.